Hello everyone. Let's begin with a prayer. Our Father, who art in heaven, hallowed be thy name. Thy kingdom come, thy will be done on earth as it is in heaven. Give us this day our daily bread, and forgive us our trespasses, as we forgive those who trespass against us. Lead us not into temptation, but deliver us from evil. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. So we are starting with section 10.1. It's about inequalities. An inequality is a statement formed by placing an inequality symbol between two expressions. So you can say 2x is less than 3. This is an inequality statement. Solution of inequality is a set of numbers that produce true statement when substituted for that variable. Do not worry about that. You will learn when you solve the inequality statements. Open circle, you know that you used open circle for less than or greater than, and closed circle if it is less than or equal to, or greater than or equal to. Now x less than or equal to negative 2, how do you graph it? So this is equal sign, so that's a closed circle, right? Now if it's x less than negative 2, so there is no equal sign, so how do you graph that? Yes, so that's you get an open circle, right? Now, which inequality matches the graph below? So start from this, an open circle at negative 2 and all the numbers above negative 2. So this is the solution, right? Now, compound inequalities consist of two inequalities joined by the word and or. So graph the compound inequality. So there are two inequalities and it's connected by the word and. So how do I graph this? So if I have 3 and 10, so this means x greater than or equal to 3 and less than or equal to 10. So everything, so this is open circle here and a closed circle over here. So 3 is included but 10 is not included. So this is these are the numbers that satisfies this inequality. This is the compound inequality. Now classify as true or false. Negative 4 less than 1. Yes, 1 is greater than negative 4 and 1 is less than 2. So this is a true statement. So this means 8 is greater than negative 4 and 8 less than 2. It is not, right? 8 is not less than 2. So it's a false statement. So this is like, so both conditions have to be true in order for the statement to be true. But if it says negative 4 less than 8 or 8 less than 2, negative 4 is less than 8, that's correct, and this is less than 8 less than 2, that's wrong, right? But then since this is or, one of them, if one of the conditions satisfied, then it is a true statement. So but if this is like, this means 8 is between negative 4 and 2. So 8 is greater than negative 4 and 8 is less than 2. So this is different from this is and this is or. Now classify as true or false again. So this is a double negative. So that means 2 is less than 3. So that's a true statement. And this is what? 3 greater than or equal to 3. Yes. Greater than or equal to 3. So this is a true statement. It is 3 is equal to 3, right? Now negative 13. So when you take the absolute value, it will be 13. It's less than 12. Yes, it is 13. No, this is not a true statement. So it's a false statement. Now solve for y if this is the inequality. So all you have to do is if y belongs to the set of these numbers. So basically you plug in the value of plug in the values for y. So when y equal to -1, what do I get? -1 plus 5, that is 4. 4 less than or equal to 7, yes. Then y equal to 0, what do I get? It's 5 less than or equal to 7, yes, that's correct, right? Then y equal to 1, what do I get? 6 less than or equal to 7, yes, that's correct. Then y equal to 2, so 7 less than or equal to 7, yes, that's correct, right? Now y equal to 3, so 8 less than or equal to 7, no, right? So, and y equal to 4, what do I get? So 9 less than or equal to 7, no, right? So the solution is, the solution set for this y is what? -1, 0, 1, 2. So 3 and 4 does not satisfy this inequality. Now, turn to page 462 and 463. This is the property of comparison. We'll just go over it. It's like, this is just kind of review in terms of, the only thing is we are this is all about inequalities. So what are the properties of comparison? When you compare with a less than, greater than, or an equal sign, right? It's either a less than or 3 less than 2 or a less than b, like that. Now, transitive property order, if a less than b and b less than c, then that means that a is less than c. So 2 less than 3 and 3 is less than 10, then you know that 2 is less than 10. So that's the same thing. Addition property of order. So I can add, just like addition property of equality, you can add, if you have equation a is less than b, I can add or subtract a same number from both sides of the inequality. So you can add a plus 2 is less than or equal to less than b plus 2, or a minus 2 less than b minus 2. In multiplication property, I can multiply both sides of an inequality by a number. So it will be 3a less than 3b. But if you multiply or divide by a negative number, then you need to reverse the direction of the inequality. We will go over it in detail in a few minutes. So, you solve an inequality by writing an equivalent inequality with the variable isolate. So basically, you are isolating the variable again. So there's nothing new here. So the solution of inequality must be graphed. That's it. That's an important thing that you should remember, because for inequality, the solutions, it will be solutions that is infinite. Most of the time it's infinite. So we need to actually show the graph. So m plus 5 greater than or equal to 2, greater than or equal to 10. So what do? I subtract 5 from both sides. I need to isolate, right? Isolate the variable. So m is greater than or equal to 5. So how do I graph it? So if if this is 0, this is my 5, greater than or equal to 5. It's a closed circle going in the opposite, on the positive direction. Now, negative 10 greater than x minus 12. So remember, an inequality can be read from left to right or right to left. But I always suggest to keep the variable on the left. It's easier to kind of see and look at the problem. So how do I isolate this variable? So I'm going to add 12 to both sides. So I get 2 is greater than x, or you can say x is less than 2. So so if this is 0 and this is 2, x is less than 2. So this is open circle going left. Now 1 is greater than or equal to x minus 9. So I need to add 9 to both sides to make x alone. So this will be 10 is greater than or equal to x, or x less than or equal to 10. So how do I do that? So this is 10. So x is less than or equal to 10. So it's a greater than equal to, right? So there is a closed circle going in the left direction. Now, how do I make t alone? So I'm going to add 7 to both sides. So t is less than 10.4. So if I say this is my 10 and this is my 11, so 10.4 will be somewhere here, and t is less than 10.4. 10, yeah, so going in the negative direction. These are all review for you, right? Now, inequalities using multiplication or division. So when you multiply or divide each side by a positive number, you produce an equivalent inequality. When you multiply or divide each side by a negative number, you must flip the inequality sign. Otherwise, it doesn't make sense, right? So for example, if I have 3 less than 15, I'm going to multiply both sides by a negative number. I'm going to multiply both sides by negative 2. What do I have? So negative 2 and negative 2. So what do I get? Negative 6 less than negative 30. Does that make sense? Negative 30 is, negative 6 is here and negative 30 is here, right? Negative 30 is not bigger than negative 6, right? So we need to, whenever you multiply by a negative number, when you multiply or divide by a negative number, you need to flip the inequality. So it should say negative 6 is greater than negative 30. Now, how do I solve it? Again, subtract 3. So a is less than 8. So again, so this is 8, a less than, open circle going in the negative direction. So this one, I'm going to add 7 to both sides. So I get 0. 0 is greater than or equal to negative 2k. Now I need to divide both sides by negative 2. So remember, I need to, when I divide by a negative number, I need to flip it. So this will be 0 less than or equal to k. Sorry, did I mess up? Yes, sorry. This, you're adding, right? I'm sorry. So this will be what? 14 is greater than or equal to negative 2k. I'm dividing both sides by 2. So I get negative 7. So negative 7 is less than or equal to k. Or k is greater than or equal to k. K is greater than or equal to negative 7. So if this is negative 7, so this will be the graph. Always show 3 points. So this will be negative 7, this will be negative 6, and this will be negative 8. Now, how do I solve it? I want to get rid of this 3 by multiplying the whole thing by 3. So I get 0 is greater than 18 plus 2d. Now I subtract 18 from both sides. So I get negative 18 is greater than 2d, or d, or negative 9 is greater than d, or d is less than negative 9. So the graph will be this. If this is negative 9, so this is negative 10 and this is negative 8, less than, so this is the graph. Now, so the 5v minus 5 greater than 3v plus 12 minus 5. So 5v, so 5v minus 3v is 2v. I'm adding 5. So the 5 will be 5 cancels out. So all I have is, so v is greater than 6. So this will be, if it's 6, so it's 7. This is 5. 5 is greater than 6 will be this. So that's basically it. So